Hi everyone, the purpose of tonight's video is to help us review and prepare for our upcoming test on polynomials. Please feel free to pause the video at any time to record your notes, fast forward to any point in the video or packet that you know you need to see, and also of course you can rewind anytime that you might want to watch something again. Let's get started. As far as exponent rules go, we definitely want to remember maths. So when we multiply like bases, we know we have to add the exponents. And if we're dividing like bases, we subtract the exponents. A good thing to do when you're confused is expand. We've practiced a lot with expanding in class, but expand anytime you're in doubt of the shortcut. For example, x cubed would expand to x times x times x. We also want to make sure we remember our rules for negative exponents. Cross the line and change the sign. And 0 as an exponent always simplifies to 1. I'll give you an example. 5 to the 0 is 1. Here, cross the line and change the sign. If I had x to the negative third, it would end up being the same as 1 over x cubed. It ended up crossing the line on the fraction, and that's what resulted in the change in sign for the exponent. Now, for multiplying monomials, we want to multiply coefficients, keep the base, and add the exponents. I have an example here for you. The word product is very important. Anytime you see product, that means the result or the answer from a multiplication problem. So it's telling us that we indeed have to multiply this 8x and negative 2x cubed to get negative 16x to the fourth power. As far as dividing monomials, similar rules. Divide the coefficients, those are the numbers in front. Keep the bases still, this time subtract the exponents. I have this example here. The word quotient, if you see the word quotient on your test, that indicates you should be dividing. 50 divided by 5 is 10. X squared divided by x squared, when you subtract the exponents, you get 0. Y to the 5th, y to the 7th, when you subtract the exponents, you get a negative 2. This y to the negative 2nd had to cross the line to change the sign, and this x to the 0 is no longer there because it simplifies to be 1. If you had expanded this one, it may be useful. You can still get the same answer by showing x times x, y, 5 different times, and then x times x, and then y, 1, 2, 3, 4, 5, we need 2 more. And if we go to simplify, we'll see that x squared divided by x squared is all gone. These y to the 5th divided by y to the 5th is all gone. I'm left with y squared here in the denominator. And 50 divided by 5 is 10. Next up, we talked about number properties. The commutative property is when you're allowed to change the order. This holds true for addition and multiplication. 2 plus 7 is the same as 7 plus 2. X times y times z is the same as y times z times x. I change the order, the answer stays the same. The associative property is when groups change. For example, x times, and then we had y and z together. However, now I have to keep the order the same, x times y, but change my group to be around x and y instead of y and z. The distributive property is the one most commonly used within this unit. So when we distribute the term outside of the parentheses to every single term on the inside, we usually show this by multiplying with arrows. Next up, like terms versus unlike terms. I have some examples of each. And it's important that you know that like terms must have the same base with the same exponent. This is for like terms. As far as adding polynomials, we want to make sure that we know our steps. We have to break out of parentheses first, According to PEMDAS, we always have to simplify parentheses. If there is no number in front of a set of parentheses, we distribute a positive 1. Once everything is free, we can combine like terms, or CLT. For subtracting polynomials, the rules are the same. We need to break out of the parentheses the same way, except this time it often involves distributing a negative 1 or some negative value, and then we can combine like terms. Because we're distributing a negative, anytime we multiply a negative with a positive, it changes sign. Anytime we multiply a negative with a negative, it changes sign. So it's important to realize when there is a negative value that's being distributed before we combine our like terms. Multiplying polynomials. This was a little more complicated. If I had x plus 2 times x minus 3, you cannot squeeze in a positive or negative 1 there. They want us to multiply. There is technically 2 pieces in this first polynomial. We have to break it up into pieces for step 1. This first piece is x, and it wants to reach across to the x minus 3. So I show that. I want to distribute x to x minus 3. We know how to distribute a monomial with a binomial. And then now I have this second piece over here, the positive 2, wants to also distribute to x minus 3. So here you can see each of the 2 pieces separately can be distributed to keep our information organized. After distributing, everything will be broken out so we can combine like terms. So here I would have x squared minus 3x plus 2x minus 3. Like terms here, same base, same exponent. Our final answer would be x squared minus 1x minus 3. Okay, here you can see I've already filled in some important pieces. Anytime you see product, we mentioned this before, I need to multiply. Quotient indicates that I should divide. Sum is the answer to an addition problem, and difference is the answer to a subtraction problem. For area, we've most often been using base times height or side squared for a square. Could be a rectangle, but any shape. Perimeter is when we add up all of the sides. A polynomial is anything made up of 2 or more terms. And then here I have some definitions and examples of the following. A binomial has 2 terms, trinomial has 3 terms. Standard form for all answers is when your highest exponent term goes first and your constant term is last. They go in decreasing order. A constant, the term that goes last, is a number without any variables attached. A coefficient is in front of a variable. And like terms are the same base with the same exponent. This is a little repetitive to the previous page, but now you have all of your terms here. Also, for some extra practice, you can open up your textbook and review any of the problems on here. I believe the answers to any of the odd problems are shown in the back of your textbook. So for some extra practice, go to the following pages, try some odd numbered problems, and check your answers in the back. All right, let's get started with the questions. Okay, Mr. Goldberg asked his son to give an example that illustrates the distributive property. Which of the followings can be used? Can his son use to demonstrate the distributive property? Here I have A on the outside. I know I would want to distribute. Let's see if it's equivalent. A times B is AB. A times C is AC. So right now I'm thinking choice A. But it's always a good idea to check all 4 choices before choosing your answer. Here I have A plus B plus C equals A plus B plus C. This was a change in groups, which actually indicates the associative property of addition. That's an A plus. Not my final answer. Choice C, A times B times C, A times B times C. So again, now I have a change in groups. This time it's A times for associative property of multiplication. The last choice shows AB plus AC is the same as AC plus AB. This was a change in order, which indicates the commutative property of addition, so it would not be my final answer either. I am going to go with choice A. Which equation illustrates the associative property of addition? Okay, so again, for the associative property of addition, like this example here, I need a change in groups. X and 2 are grouped together here. There's no group on this side. 3 plus X is grouped together here. Now X plus Y. This shows a change in groups. Choice C is the correct answer. Okay, what is the product of 2x minus 1 and 3x plus 2? We learned before that product means I need to multiply. So let's take a look at 2x minus 1 times 3x plus 4. There are two pieces in this polynomial, my first piece and my second piece. I am told I must break apart my first polynomial into pieces. So I have 2x that multiplies with 3x plus 4. And then I have my second piece, negative 1, which has to multiply with 3x plus 4. Next up, I distribute to break everything out. 2 times 3 is 6. Multiply your coefficients. Keep your base. Add your exponents. Now I have 2x times 4 becomes 8x. A negative 1 times 3x becomes negative 3x. And a negative 1 times 4 is negative 4. Now I look for any like terms. I have two like terms in the middle, one pair, so 6x squared remains. 8x minus 3x is 5x for the middle term, followed by the constant at the end, negative 4. I see choice A is the correct answer. Let's move on to number 4. This problem looks similar. However, I see that there is a negative 4 here. If I read this, it says 5 times this binomial. And you can read this as subtracting 4 times this binomial. This problem is not the same exact setup at the beginning. So here, to break out, I can start with distributing that 5 to get 5x, and 5 times negative 3 is negative 15. I can now distribute to break out here, but I have to be careful. It's negative 4x that's being distributed, negative 4 rather, to get negative 4x, and negative 4 times negative 3 is positive 12. Now I look for some like terms. 5x minus 4x, make sure you circle that sign with it, is 1x, and then I have negative 15 plus 12. We've been talking about SADs in class. If this helps you, use it. Negative 15, positive 12, they're different signs, so I subtract the numbers to get 3, and then I realize that it's going to be a negative 3 because 15 was negative. 15 had a larger arrow. If I was using a number line, I'd remain on the negative side of 0. My final answer is 1x minus 3, which is equivalent to x minus 3. Okay, another properties question. This time, we're looking for the commutative property, CO, change in order for addition. So C plus, 3, 4, 7, 3, 4, 7. There is no change in order. A, B, C, B, A, C. Looks like a change in order. X, Y, Z, Z, X, Y. Also sounds like a change in order, so possibly. And then here, I see the distributive property right away. Between B and C, I have to be careful. I am going to use choice B because it's showing it over addition. Choice C is C, commutative property of multiplication. Let's begin number 6. It says if A is this trinomial and B is this trinomial, then find A minus B. So we have A minus B. Let's Let's start with the setup. It's important to show parentheses to group that I had A first, this trinomial, and then we are to subtract B, negative 2x squared minus 6x plus 7. Now our steps for adding and subtracting polynomials begin with breaking out of parentheses. To break out of this set, I see a 1. When I distribute this 1 to all three terms, they remain the same, but at least now they're free from their group so that they can mingle with any like terms that may occur through on the other side of the problem. Here, to break out, I put a 1, but it's really a negative 1. This negative times a negative becomes a positive 2x squared. A negative times a negative again is a positive now, 6x. And then this negative 1 times 7 becomes minus 7. Now I can combine like terms. 3x squared plus 2x squared is 5x squared. 5x and 6x combine to 11x. Negative 6 minus 7 more. Again, if you're confused, use SADS anytime you're combining like terms. This time they're the same sign. I add them. So I get negative 13. Always keep the sign with the larger number. Here is my final answer in standard form. Highest exponent, decreasing order, constant at the end. Number 7, product. I see the word product again, meaning multiply. I have to multiply 2x squared plus 7x minus 10 with x plus 5. Now here I see I have 3 pieces. 1, 2, and 3. I have some choices. I can still break apart these 3 pieces, as the first step says, break up your first polynomial into pieces and distribute each piece to the x plus 5. However, using the commutative property of multiplication, it might be easier to break apart these 2 pieces. So for commutative property of multiplication, I know x plus 5 times 2x squared plus 7x minus 10 is actually equivalent to the original. And in this case, I only have 2 pieces to break up. Ultimately, you do the same amount of work. You end up finding the same, let's say 6 products, and then you combine like terms to get the same final answer. It's a matter of preference. So maybe I'll start with the original problem in case that's how most of us solved it on our own. Alright, so my first term, this 2x squared, has to distribute across to x plus 5. I also have 7x that has to distribute across to x plus 5. And then my third piece, negative 10, must distribute across to x plus 5. Let's distribute and break out. We now have 2 times 1 is 2. X squared times another x becomes x cubed. 2x squared times 5 is 5. It remains x squared. Oh, actually, I didn't multiply my 2 and 5. 2 times 5 is 10 x squared. Okay. I now have to distribute my 7x. 7x times x will stay 7, but become x squared. 7x times 5 is positive 35x. I now have negative 10 times x, negative 10x. Negative 10 times 5 is negative 50. Let's look for like terms. 2x cubed has no like terms, so 2x cubed is part of my answer. I now see 10x squared, 7x squared. They combine to 17x squared. We have 35x minus 10x. That's a positive 25x, followed by the constant term, negative 50. Here's my polynomial answer in standard form. Number 8. I hope you're realizing right away that this is what we need to look out for. Before I can start this problem, I want to break out of these parentheses, but I can't put a 1 here, although it is there. This 1 is here. I'm not allowed to distribute before I handle exponents, according to PEMDAS. The distributive property uses multiplication. I still have to take care of this exponent and these parentheses before I can do that. So, to square something means I have x plus 4 times itself. And then I have this subtract 5x at the end. Now here, I see a binomial that has to distribute to another binomial. I must break this first polynomial into pieces. My first piece is x times my x plus 4 from over here. And now my second piece is this positive 4 right there to this x plus 4 over here. And then we don't want to forget, we still have this minus 5x at the end. Let's keep this expression equivalent to the one above. Now let's distribute. We now have x squared plus 4x plus 4x plus 16 minus the 5x. I have x squared in my final answer. 4x plus another 4 is 8. But now 8 minus 5 is 3x plus 16. Here's our final answer in standard form. For number 9, similar problem. I have my first term, my second term. Let's break them apart. M has to distribute to m plus 2, followed by negative 2 has to distribute to m plus 2. We can now distribute m squared plus 2m. Negative 2 times m is negative 2m. Negative 2 times 2 is positive. Nope. Negative 4. Negative times a positive is always negative. I now combine like terms in the middle. 2m minus 2m combines to 0. So I now have m squared minus 4. Here I have two pieces again in my first term, in my first polynomial, that need to distribute to a trinomial. So let's take a look at this x has to distribute across this trinomial to x squared plus 3x plus 4. And this negative 1 needs to distribute across to this 2x squared plus 3x plus 4. Let's distribute. Distributing to break out of the parentheses so I can find any like terms. I have 3x squared here. X times 4 is 4x. I have to watch out. This negative is going to change the sign. Negative 2x squared. Negative 3x. And negative 4. Let's combine any like terms. 2x cubed is my first term. 3x squared minus 2x squared means I have 1x squared. I have 4x minus 3x, I have 1x. And then my minus 4, the constant at the end. Here's our solution in standard form. Ooh, I have choices here. This time I'm going to show you how to use the commutative property. I definitely would prefer to distribute 2 pieces rather than 4. My preference, will it work still the other way? Absolutely. So through the commutative property of multiplication, I can rewrite this original problem as y minus 1 times y cubed plus y squared plus y plus 1. Now, I'll show you my two pieces. I have y and negative 1. Let's start off with distributing y to the, the polynomial as 4 terms. May have misspoken before and called it a trinomial, but this has 4 terms, so let's look at that. Y times that polynomial, and now negative 1 has to distribute to the same polynomial. Y cubed plus y squared plus y plus 1. Okay. Y times y cubed, be careful, y to the 4th. Y times y squared is y cubed. Y times y is y squared. Y times 1 is just y. Negative 1 times y cubed is minus y cubed. Negative 1 times y squared is negative y squared. Negative 1 is going to change the sign of this term and the last term as well. Y to the 4th is in my answer. Y cubed minus y cubed combined to 0. Y squared minus y squared combined to 0. Y and negative y combined to 0. I am left with y to the 4th minus 1. We now need to complete the following chart, filling in the missing expression in the rectangle first, and then the missing properties in the circles. Okay, so this rectangle, I can't exactly connect this way to figure it out because I'm not sure what property goes here. Same here. I must use this arrow to figure it out. The associative property of multiplication states that I cannot change the order, but I can change the groups. So let's keep the same order and change the groups. Let's group 3 with this x. Okay, now let's look this way. X and then 3 and x changed order. So change in order of multiplication. Alright, now going this way. X, 3x, 3xx. There's also a change in order. Began with x, here it finishes with x. Let's take a look this way. 3, this starts with x. X, this goes to 3. We now changed order right here. Commutative property of multiplication again. Let's look this way. 3xx, 3xx. No change in order, but I did change from grouping 3 and x together to x and x. A change in group is associative property of multiplication. Let's look for a change in order again. 3xx, xx3. I did find a change in order, so it's c times for commutative property of multiplication. Okay, we're almost all the way around. Let's take a look here. xx3, xx3. Different groups. X and 3 are grouped together here, x and x here. Associative property of multiplication. And our last step, x3x, xx3. I did change order. X and 3 are still grouped together, but I changed the order for the x. So it's commutative property of multiplication. I hope you found this video useful. Of course, you could have skipped ahead, rewound, paused to record. Any other questions, please remember to see me for extra help. Thank you.